In preparation for proofs that we'll do in geometry, we'll start with an algebraic look at things and eventually make our way over to some of our geometry properties. So in algebra, we have properties of equality. Anytime you're solving an equation, you are using one of these properties. When you solve equations, and all of them start the same if A is equal to B. And this might make a little more sense if you take notes using some different colors today. So if the left side is equal to the right side in algebra, the addition property simply says that it's okay to add something to the left side of the equation as long as you also turn around and add that same something to the right side. That keeps the equation balanced. What you do to one side, you also end up doing to the other. So you're adding the same thing to both sides and the equation remains balanced and equal. So the same thing is going to be true for subtraction. If we subtract some value C from the left-hand side, we'll also need to subtract C from the right-hand side. Let me be sure I have pens that actually work. Okay, all right, so the multiplication property says if you take that A and the B, that if you multiply A by some value C, that's legal as long as you do it to B. And the division property, of course, says if A is equal to B, if you divide A by C, that's legal as long as you also divide B by C. So those are properties of equality, and we did those all the time in algebra last year. The distributive property was also used. So to distribute means to pass out or to pass through. So we're going to distribute or pass this quantity through. So you have a number times a sum, passing that value through the quantity. So if you multiply, then A times B plus A times C, those would be equivalent to one another. In either direction, you're using the distributive property. The substitution property, if you substitute something, you replace it with something else. So if A is equal to B, if those values are the same, then A may be replaced by B in any expression or equation. You can replace an equivalent quantity. And then these remaining three properties are alphabetical, and they're kind of old school algebra properties. We don't talk about them in algebra much anymore, but notice it's RST. Reflexive kind of sounds like your reflection in a mirror. This is going to have one equation. S will have two equations. The transitive property is going to have three equations. RST, 1, 2, 3. That's one way to remember it. But if you have any real number A is equal to A. Anything is equal to itself. It's like looking in a mirror. What you see back is your own reflection. The symmetric property says if some quantity A is equal to another one B, symmetry, it looks the same on the left as it does on the right, then you can simply switch this around and say that B is equal to A. The transitive property, so this is just like a left-right thing where you're swapping out the left and the right. The reflexive property, you can think of a reflection. And the transitive property, I want you to think of cutting out the middleman. Okay, take the middleman out of the deal. So there'll be three equations. If A is equal to B, and three quantities, and B is equal to C, so the thing that's in the middle is the B. So the first quantity could be, we can just say the first is equal to the last since they both equal B. Then A is equal to C. That's an example of the transitive property. So let's do a couple of problems down here where we'll have some practice using those properties that we haven't seen as much, and then we'll finish the rest of these in class. We'll do 3, 5, and 12, and then a quick proof. So 10 times y is equal to 10 times y. Notice that there's one equation, and the left side looks exactly like the right side. It's much like a reflection. Anything is equal to itself. This is the reflexive property. Number 5, we have 1, 2, 3 equal signs. So that's my first clue that this is possibly the transitive property. But notice it says that 10A is equal to 2B, and then that same 2B is equal to C. 2B is our middleman, so we're going to be able to cut out the middleman and simply say that the first is equal to the last. That is an example of the transitive property. And then number 12. So here's our expression, 3 times x squared plus 1, and we know that x is equal to 5. Well, what changed? When we rewrite this expression over here, notice that the x has simply been replaced with a 5. We plugged a 5 in, so we are using the substitution property. We're replacing something with its equivalent value. Okay, we're gonna practice that. What I'd like you to do is have a page in your notebook, let me zoom out just a little, where we will staple this in down below. I just need a short little space up above, and we're gonna just quickly do an algebraic proof. So how do we use those properties to do an algebraic proof? So in any proof, you're gonna have given information that's free to you, and then something that you're trying to prove. You're not finished until you state this statement right there, okay? So this is when you know that you've reached the end and you're done. So let's start with our given. So what do I know? I know that this is the problem that we need to examine. This is what we get to start with, and we'll manipulate this to prove that x equals -1. These are our reasons. So this is called a 2-column proof, where we have statements and reasons, a 2-column proof. So how did I know that? Well, I knew it because it was given to me. And your proofs will always start like this. You take the given information and write it down, and then you work with it. Well, let's use our algebra skills. If I'm solving for x, I could go ahead and multiply the 2 through the parentheses. So we'll have 2 times x plus 2 times 1 is 2. So what did I do going from step 1 to step 2? What changed? I passed that 2 through the parentheses. I used the distributive property. Okay, next, if I were going to solve for x, I would need to, you won't always see this written, but what we would do is we would subtract 2 from both sides. Chances are that's not going to be written. Instead, the next line would simply look like 2x is equal to -22. So how did we get from here to here? We used the subtraction property. And these are all properties of equality, okay? So we use the subtraction property of equality. So what would we do next? The next thing we would do is we would go ahead and divide both sides by 2. Again, that might not be written. The next line may simply be x equals -11. So from here to here, we use the division property of equality. And how do I know there's nothing else to do? Well, I've reached my end goal. I was asked to prove beyond a shadow of a doubt that x equaled -11, and I did that in 4 quick steps. So we'll practice some more algebraic proofs. We'll practice some more with these properties, and then we will move on and start looking at geometric proofs.